Hello again. Here's your Week 8 MyStatsLab Problem 8 example. And in this problem we're talking about in the 1980s, it was believed that congenital abnormalities affected about 6% of a large nation's children. Some people believe this is due to an increase in chemicals in the environment, and we have a recent study examined 376 randomly selected children and found that 53 of them showed signs of an abnormality. Is this strong evidence that the risk has increased? And we are considering a p-value of around 5% to represent reasonable evidence. Part A asks us to write an appropriate hypothesis. Well, since our problem states that about 6% are affected, then it makes sense that our null hypothesis should be that p does in fact equal 6% or 0.06. So our alternate will be that this probability is greater than, so p is greater than 0.06. Part B asks us to check the necessary assumptions. Assumption 1, that data are independent, and since we know that one child's condition does not affect another, then we can say that our data are independent. We'll give that a check mark. Part 2, the data must be sampled at random. Well, the problem states 376 randomly selected children, so we can assume that that is correct, and we can check that one off as well. Part 3, less than 10% of the population must be sampled. Well, since this is a large nation, we can assume that 376 children would be less than 10% of the population, and we can check that one off also. And then assumption 4, it must be expected that the sample contains at least 10 successes and 10 failures. Well, since we're looking at this PO to be 0.06 as it says in our problem, then if we take the number in the sample, 376, times this probability of 0.06, we come out with 22.56. And then on the other side of that, 376 times the 94, which would be our Q, gives us 353.44. Therefore, we can assume that there are more than 10 successes and more than 10 failures. We can check off that box also. So now we can move on to Part C. In Part C, we're asked to perform the mechanics of the test and what is the p-value. So for that, we're going to find the standard deviation, we're going to find the z-score, and then we'll find the p-value. So the first thing we need here is to find p-hat, and we're going to use our numbers in our study, 53 and 376. So we will say equals 53 divided by 376, which is our n, and we get p-hat to be 0.1410. We already know that p0 is 0.06, so q will be equal to 1 minus that number, 0.94. Of course, n in our problem is 376. Place that there, and now we can find the standard deviation of p-hat. With our problem here, standard deviation of p-hat is the square root of PO times QO divided by n. So in this blank, we're going to go equals, start typing, square root. So when it pops up, we can double click there. Put in, let's put in an extra set of parentheses. So PO times Q. We'll close those parentheses. Divided by our n. Close again. Hit enter. And there is our standard deviation at 0.01225. Now we can find z. Z asks us for p hat minus po divided by the standard deviation of p hat, which we just found. So we can go to our block here, equals, and in parentheses we'll go p hat minus p0, close our parentheses, divided by standard deviation, hit enter, and now we have our z-score. Our z-score is large, 6.61. Now from there we're asked to find the p-value that corresponds to this z-score of 6.61. I'm going to do this a couple of ways. First way I found is a neat little website which I have copied and pasted here. Let's click on that and go to the website. And here we can go 2p from z. Come on back. Here we go. With 6.61 is our z. Click on compute p, and we'll get a number very small. This is saying less than 0.0001. That's one way we can come up with the z-score. We can also go back to our spreadsheet and let's let phstat do this for us. So we can go to add-ins, phstat 2, and we have a one sample test, and we'll do the z-test for the proportion. Let's see if we can get it to come up here. Let's try it again. One sample test, z-test for the proportion. There we go. Our null hypothesis, as we know, is 0.06. The level of significance, since we were talking about 5%, is 0.5. The number of items of interest, that's our 53. And our sample size, of course, is 376. We can enter that also. This is a one tail upper tail test. Click OK. And there we have, look at our data here. There's the z statistic there at 6.61, which we've already calculated the other way. And there's our p-value, 0.0000. So we can say that our p-value is 0.000 and as many zeros as you want. Now on to part D. Explain carefully what the p-value means in this context. Well, I've written here the p-value is the probability of getting data like the observed data given the null hypothesis. In this context, the p-value is the chance of observing 53 or more children with genetic abnormalities in a random sample of 37 children, if 6% of the children actually have these abnormalities. Part E. What is your conclusion? Well, since the p-value, very small, is less than the level of significance, which we considered at 0.05, then we reject the null hypothesis. Therefore, there is sufficient evidence that more than 6% of the nation's children have abnormalities. And on to part F. Do environmental chemicals cause congenital abnormalities? Well, does the outcome of the hypothesis test indicate the cause? I'll let you decide on that one. And that's it, guys. That's your week 8 MyStatsLab problem 8 example. See you next time.